Question number D. This is a continuation with the previous two videos that I have done already. This was a part of a series. What to do is, if you want to know about this, if you are looking at it independently, go back to the two videos and then watch this so that you understand this problem. Okay, so another sphere is dipped into the water. Okay, earlier we had only one sphere which has been dipped. See, I will show you how the experiment was conducted. The experiment was conducted like this. See, only one sphere was dipped over here, the motor was there, the motor was rotating like this, and as a result of it there were waves which have been created like this. Now what you do, you put one more sphere, okay, somewhere over here, and then what you do is, there is a motor here, and now you put a pipe here, and as a result of it, or maybe put one motor, put a pipe connected to this, okay, and then there are two parts which have been oscillating like this continuously. Okay, now coming back to this, now what does it tell you? So two waves are being generated simultaneously, and they are being simultaneously interfering. Now let us look at this. The spheres are oscillating in phase. It means what? If this is the what do you call it, a rod connected to the motor here, the motor rotates and this rod starts vibrating like this. Here are two spheres connected here. Two spheres are connected like this, and if this is the water surface, it starts vibrating like this over here. It starts vibrating like this over here. The diagram shows some lines in region A along with the disturbance of the water surface. See, this is the disturbance. This is the waves that are being created. Circular waves are created, and one of these waves falls onto the other. See, the lines that are shown over here tells you that the waves are superposing. So outline how regions of the minimum disturbance occur on the surface. How do you get minimum disturbance? What is this happening? This is nothing but a case of YDSE experiment. What is YDSE experiment? Young's double slit experiment, right? You had two slits and then waves are passing through it. In a similar way, so here two waves are created synchronously over here. Now outline how the regions of minimum disturbance occur on the surface. Now when do you get a minimum disturbance? So this is for 3 marks over here. So you need to write something like crest of one wave falls on trough of the other wave. Right? So this will give you 1 mark, right? Then the secondary. So next is, what else can you write? You can also write something like phase difference between two waves should be equal to 180 degree. Okay, this is the third one, second one which you get. So you again get 1 more mark here. Then the third one is that what happens over here when you say net disturbance equal to 0? Net disturbance, or maybe you can say net displacement, resultant displacement due to both waves is equal to 0. So if you write these 3 points, then definitely you will get 3 marks over here. Okay, so it is not the question of how much knowledge you have, but you should also know how to represent it properly in your paper. Okay, let us move on to the next one. The frequency of the oscillations of the spheres is increased. Okay, what is now happening? The frequency is increased. State and explain how this will affect the positions of the minimum disturbance. Now what is happening? Now you are having these two spheres which are now slowly vibrating like this. And when you say frequency is increasing, what's happening? Dun, 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 dun. So it's vibrating faster and faster like this, right? So as a result of it, what will happen? You get more number of waves. When you get more number of waves, okay, so we want to know how are the positions getting changed or affected. So towards it, first thing is, when you increase the frequency, now we know the positions of each of this minima. Okay, this was your YDSE experiment. You got several minima over here, and you wrote something like xn, the position of the minima from here is equal to n into capital lambda into d divided by d, right? Now you see the value of d is not increasing. What is d here? This was the two sources. This is your d here. This d you are not going to increase, right, by doing this one. This small d, this also you are not going to increase. Distance between the two spheres not increasing. What is changing here? Lambda is changing over here. So now if frequency is increased, lambda will decrease over here. When lambda decreases, what happens? Xn decreases, which means what? So earlier this was your x1, this was your x2, right? Now this x1 will now become d here, right? x2 will be here, x3 would be here, x4 would be here, right? So it becomes more number of minimas have been present. Now this is for 2 marks over here. So therefore first mark goes for this, writing the proper formula. Second mark or first mark, along with this you need to mention this also. Second mark says, okay, second mark you can say when f increases, lambda decreases. As a result of it, xn also decreases, right? So they cross 5 minutes, okay? So thus we can say xn also decreases. So and hence the positions will be nearer, okay? So with this we come to an end for today's problems, which had 3 parts, okay? Go through the problem completely so that you understand it clearly, right? Thank you.